Let us start by identifying what are the most basic features we need in order to implement this project. Okay, first of all, we do need a timer to keep track of time. Then we need a buzzer, a speaker, or a super powerful LED, something to wake you up at the alarm time that you set. And then we need a way to display the time. In this case, for simplicity's sake, I am using a UART to transmit the time data directly to a UART console, like we showed before. And that's it. You can use basically any microcontroller available from ST. It's just you need, I am using, because in this here you see that, for instance, L0, STM32 L053R4 is more than enough. It is, I think, one of the most widespread Nucleo boards, so that's why I'm putting this here. But that's it. In our specific implementation, we are using the low power timer 1 as a time reference, and we are using a timer 2 connected to a buzzer. You can still use it without a buzzer, because of course I'm using the timer 2 specifically because it's connected to the LED here. Okay. Then finally, as I said before, we are using a UART plus a computer to show our time. Of course, as I said before, you are a lot of possibilities to implement the same feature set. I advise to explore and redo this project by yourself. Of course, I will provide the project files in down below. Okay. Again, for the microcontroller settings, we are using a sleep mode and setting the voltage reference range to the lowest that we saw before. It's in this case 2. And since I'm using the timer 2 for giving the output on the LED, I am obliged to use only the sleep mode and not the stop mode. Okay. Because otherwise the timer 2 will be completely off, so I don't want that, of course, because I want the program to work, of course. Okay, I am setting the low power timer with a clock source of 32 kHz, and I am using a prescaler of 32 to basically give one clock impulse equivalent to 1 millisecond. In this case, if it's needed, you can even use the sys clock if you want to go like let's say without using interrupts and low power modes eventually. The timer 2 is connected to a 2 MHz clock source, and it's generating a PWM waveform. Let's look very fast at our super basic, actually, of course, block diagram of the algorithm we are implementing. So first of all, we set up everything, especially including the timer 2 and the low power timer 1. Every 60 seconds, so we have that the low power timer 1 is counting it's giving impulses of 1 millisecond. Each 60 seconds, what we are doing is we have we have to update the displayed value that we will show on the UART. Then after, if the timer is the alarm time, we will activate the timer 2 in PWM mode for our alarm. Then I have also implemented the button, the blue button here, for eventually stopping the timer 2 and hence the wake up, basically. No, we don't want our project to be very annoying all the time. That's the spirit. Okay, let's go to okay, I will open in this case the workspace that I had already created for my projects, and let us also destroy the like, I'm not of course destroying it, but I am taking this project out, the alarm project, so I can show you how to import the projects. So you just have to go to File, Import, Projects from Folder or Archive. Then you have to click on the directory button to manually, if you want to manually find a directory. You can also import from an archive, same thing. If you already have the folder structure of where your file here is, you can put it here. I think I have it here, yeah, it's this one, but eventually it's best I can show you like a directory. It's in this workspace, a low power class design, alarm UART low power timer, select, and then it will show you the project that you are going to import. It is this one. Select, double check it's selected, and then you can import it. You can create also a working set and add it to that. You will just have to create a new working set with a new button and say, okay, it's a resource working set, and so on. And then you have to select to choose a name with for the working set, and all the projects that will stay there. I'm not doing this because it's really not useful in this case, but it is basically a way, a working set. It's a way to subdivide the projects even more. Okay, so like you are basically creating a subcategory of these projects. So let's go to finish, and now it's magically imported. A lot of magic. Let's look very fast at our io.ioc file to check that the configuration is good. And okay, clock configuration, I have put 2 MHz. So the clock 2 MHz is the same for, in this case, the UART, the system, the CPU, and also the timer. The timer 2. Yeah. For the low power timer 1, I am using the LSE source, which is in this specific microcontroller, it's 32 kHz. I think if you use the L0, the only difference that you will have eventually to change, it's that this one is by default 37 kHz, but yeah, ideally you will have just to double check that. Okay, I've configured this project in such a way that eventually changing this should be straightforward, but okay, eventually do as you wish. I am connecting the buzzer on the PA5, as I said before. So basically, in this case, I am giving you two options, like PC1. I can use either PC1 or PA5. PA5 is the same output as the LED, so I can even put this small buzzer that I have here in parallel. It will also make sound. or eventually you can use this one also, but I think yeah, as I said before, for in order to make this as accessible as possible, and also give the possibility to using the LED. Okay, the timers, you can see that the low power timer 1 is enabled and is also giving an interrupt signal, which I am using to wake up the system from the sleep mode. I have also the prescaler 32 or 32 enabled, and I have it also enabled the waveform generation in case I want to use it. But of course I'm not using it right now, so I can eventually take it out. But okay, it's okay. I will leave it for now. It's not a big issue. USART1, I didn't change anything. No, I am lying. I have changed the interrupt settings. Ah, no, sorry. It's a spoiler for the next for the next example. Don't worry. Don't go forward and read everything. I know you are doing it right now. But, okay, jokes aside. The last change I did is to actually enable, as I showed before, the blue button as an interrupt source through the NVIC tab. It's enabled. And also another advice is that after you enable everything, double check that the interrupt sources you have enabled are also enabled in the NVIC tab. You have to be sure, of course. It's a very good practice to double check. Everything should work and will work ideally by default, but not trusting the software is usually always the best idea. It's just extra precautions do not hurt. On GPIO I can be sure, okay, it is connected. And actually, one thing I didn't mention before is that when you click, it will blink to the GPIO, corresponding GPIO will blink. So eventually it is also easier to look at it by eye. Low power timer, I can see, yes, it's connected to that one. The timer is connected to that one, and so on. Actually, for the timer, if you want to change the output from PA5, you can see that there are actually other GPIOs that give the same, they are connected. So because you can see that PA5 is connected to timer 2 channel 1. In fact, if I were to disable it here and try to re-enable it here by the timer 2 tab, channel 1 is an output PWM generation. By default, it goes to PA0, okay? But if instead I enable the PA5 as timer 2 channel 1, and I enable it after, and enable the channel 1 after that, it will go directly here. I think you can change it through the GPIO settings. I'm pretty sure you could even change it after like that. Let's try actually at this point. Ah, no, okay. Yeah, if you change it, it will do it automatically, which is good. Okay. Okay, yeah, again, timer 2, I didn't maybe discuss about this. You have to, of course, try to select the internal clock source. Otherwise, it will not count anything. You can use an external source and so on. And the channel 1 must be, as I said before, connected to the PWM generation. And here I've put 200,000 per scalar, and I made sure that it's PWM mode 1. And yeah, that's it. Auto reload per load also. That's it. I don't think you have to change anything else. Pretty sure. Okay. I don't need to regenerate the code. Let's go directly to the main.c file. I can even close this one. Okay, you can see that on the main.c file, and I have something on the main.c and something also on the main.h. On the main.h is usually a good practice to keep the defines there if you want to, especially if you want to access them from other files, like if you have another .c file and your define is maybe on the main dot. If you have like a secondary .c file that you want, and you want to access the defines that otherwise you have to on the main.c, you cannot, if you will call the defines, if everything is fine, it will give you a warning. It might, at least it will give you a warning, but usually it should not work. Okay, here I have some definition for defining what is a minute. Here I've put actually 1 second. It's not correct. I put 1 second just to show quickly the wake up, I guess. How much is a tick of the timer in milliseconds? Here I put it integer 1 millisecond. The period that I want to count, basically, which I want to interrupt. For commodity reason, I put 100 milliseconds. But eventually I can even change this on the fly, but in this case, like I wanted to, I mean, in this case, I think it is like a balance of, it is understandable enough and not too confusing. I hope, at least. You will have to tell me eventually, maybe. I accept the feedback. So, CMP is compare value, so basically it is the value that will be used in the generation of the PWM waveform. And as I say, and I've put 200,000 as the period in this case. I am decreasing gradually. And I'm putting the alarm minute and the alarm hour into different variables, into integer 8-bit variables, let's say, as well as the minutes, standard minutes, and hours. I've put also machine state, which is says, okay, we have an alarm off or an alarm on. I think it is here. Should be here, right? Yes, it's here. So alarm off is 0 and alarm on is 1. Easy peasy. Okay, I have a function which is manage time that we can see here. It basically updates, we can see without going too much into details, updates the current time. And so updates, if you have a minute plus 1, it updates the minutes and the hours if needed also, and eventually checks if we are reached the alarm time. If we did, we go into alarm state and then send a proper message and start the PWM generation for having the alarm. Otherwise, it just says a random stupid message. Okay, only thing on the main side, the only thing I am doing is just launching the low power timer once to give the time reference, and then on the while I am going into sleep mode. I've put this under comment because actually the low power modes like sleep and stop mode usually don't work very well, if at all, during debugging. There are some flags you can enable, but to like simulate the workings of that of say the low power mode during debugging. But yeah, in this case we don't need such a thing, and this is easy enough to debug without. So eventually, when I would eventually want to actually deploy this in an actual device, I can just take this out and it's fine. Now it's not low power, and now it is more low power, a little more. Maybe not perfect, but it's better. Okay, we are not saying where we are calling this manage time function, and as you can see, it's not here. If you really want to search for that, you could press double click, copy eventually, use a Ctrl H to search in the files, all the files, if you don't know, but I know, of course, because it's in the IT here. And ideally, you can even use this arrow here and double click here to see exactly where it was called, okay? It is called, as I said before, from the low power timer interrupt handler. And here what I am doing is just managing the time and eventually updating if it's needed, if I am during the alarm clock. So if we are in the alarm state, sorry, I am updating the CMP value and putting that inside the counter compare register in the timer. So you want ideally to update it like this. It's just one instruction, so it's fine. Just one line of code, very simple. Idea, you could tell me, yeah, but why are you putting this inside the low power timer interrupt handler? The actual answer is, yeah, I could put it inside the manage time, and it will work the same. So let's do just that. I think here I put it before, no, after. So let us do just that, I guess. Okay. Eventually, in the version I will give you, I think this will remain where it was before. So if you want to change it after, it's up to you. I'm not going into, I can go into the debugging actually, because of course I disabled that. So let's go. Let's see how somebody will do eventually. Let's go to debugging. Keep in mind that eventually for the debugging there is a shortcut which is F11. It could be sometimes, eventually, it could be useful to use this kind of shortcuts, so you know. Okay. Adding it. Okay. I think I can open the console. Yeah, here I need to open a new one. Nucleo. Okay. Forward. Okay. Now it is actually running because in the while there is basically nothing. I guess I'm not seeing. What happens if I stop that? Okay, this is actually okay. Wait, maybe there was a reason why I kept this code here. Eventually, let me double check the configuration. Of the UART if it doesn't work. Okay. Yeah, of course. Yeah, it is a small quirk that apparently I kept. I remember. Yeah, this will be fixed actually. I will fix this actually in the version I will give you. Yeah, it doesn't send just the first message. I could just ask to basically you could even do yourself this like add the first message here manually. It's not. It is really like a stupid add-on, I guess. Okay, but now it will be super fast because I put that 1 minute is actually 1 second. It's not 1 second actually. Don't try. I'm not trying to trick you. Eventually, it will try to wake up in like 10 minutes. Okay. One thing you could do, you can add the values on the live expression. Like for instance, here you see that it's 30. We can also put the minutes and the hours instead of just the alarm. I think maybe, yeah, it's better like this. And alarm hours, I guess. Okay, you can see basically everything updating at the same rate here. If I press the button, so you can see that actually if I don't mess the USB cable, it has the LED is blinking like an alarm, kinda. I spent a good 1 minute to think about it. It's very like art. It's like art. Okay, if of course, if I press the suspend button, of course, it will continue doing this because I've stopped. The CPU is stopped, but the timer is continuing to work, and it's just you can see that the level at which the frequency at which it's blinking, that is remaining the same because I'm not updating that through this. Okay. But otherwise, everything is stopped. If I want to stop it again, the blue button that will not work now, but eventually, after I went there, eventually after I take out the pause, it would have gone. It went to the interrupt routine and stopped the PWM. Okay, let's change the alarm to let's put 2 in the morning and 10 minutes. Okay, and while it's doing that, I'm also connecting the PWM generation so we know where we are wake up. Yeah, it's very annoying. I told you, that's why I wanted the button. Now it's not annoying anymore because it's silent. And this is pretty much it for this example, actually. So I can show you, actually, the last thing I can show you is I can show you that it works even when I put in sleep mode. The UART even works. It will work. If I put if I'm just running it without debugging. Okay, so let us see. Usually one advice, if you are using the debugger, while it is still compiling, etc., and downloading the code, it is usually a good practice not to touch anything, because it can eventually disconnect and then you have to redo it